Good morning and welcome back again. I'm Miss Sandari and this is Science Equals Fun. In the previous video, we talked about attraction forces, intermolecular spaces, and continuous motion. Today, let's revise the attraction forces before we start. The attraction forces among solid molecules are very strong. The attraction forces among liquid molecules are weak. The attraction forces among gas molecules are very weak. The solids very strong, liquids weak, gases very weak. Now let's talk about the shape and volume of solids, liquids, and gases. Solids have definite shape. This means no matter where you put the solid, it will take the same shape, so it have definite shape. Liquids have indefinite shape. This means when you put water or liquid in any container, it will take its shape. Gases have indefinite shape for sure. Now let's talk about the volume. Volume means that the object occupies a space. Solids occupy the same space no matter where you put it. So solids have definite volume. Liquids have definite volume as well. So the liquids have indefinite shape but definite volume. Gases have indefinite volume. So solids have definite shape and definite volume. Liquids have indefinite shape and indefinite volume. Gases have indefinite shape and indefinite volume. Here we have a little comparison between solid, liquid, and gas, using motion of molecules, intermolecular spaces, attraction forces, shape, volume, and examples. Okay, read it. If you have any inquiries, just comment below. Now let's learn about the temperature and matter state and know how will the temperature affect the state of matter. Can the temperature change the matter from solid to liquid and from liquid to gas? Let's figure out. We already know that we have three states of matter: solid, liquid, and gas. Okay, look at these images and I want you to notice that the attraction force or intermolecular forces among the solid molecules are very strong, while the attraction force among liquid molecules are weak, and the attraction force among gas molecules are very weak. Now let's focus on the intermolecular spaces. The intermolecular spaces among solid molecules are very small. The intermolecular spaces among liquid molecules are intermediate, while the intermolecular spaces among gas molecules are very large. Now let's talk about melting process. In the previous lesson we talked about melting point and we said we should relate the word point to temperature. Melting point, it is a temperature at which the matter begins to change from solid state into liquid state. Melting process, it is the change of matter from solid state into liquid state. By what? By heating. But how does this happen? Let's see. When you ask you, give reason. Heat changes the matter from solid state into liquid state. Why? Because when heating the solid substances, its molecules gain energy and its speed increases. Of course, we're talking about the molecules. The speed of the molecules increase. So when heating the solid substances, the molecules of these solid substances gain energy and its speed increases. The speed of molecules increases. As the intermolecular spaces among the molecules increase, and the intermolecular force among the molecules weaken, so the molecules become more free. So in heating the matter, what happens? The solid matter, its molecules gain energy and its speed increase, and the intermolecular spaces among its molecules increase, and the intermolecular forces among its molecules weaken. So the intermolecular spaces increase and the intermolecular forces weaken. So the molecules become more free, as you can see in this image. Now let's talk about vaporization. Vaporization is the change of matter from liquid state into gaseous state by heating. How does this happen? Let's see. When he asks you give reason, heat changes the matter from liquid state into gaseous state. Because on heating, the molecules of a matter, the molecules gain energy, and its speed increases, and the intermolecular spaces increase, and the intermolecular forces become very weak. So it's the same thing for melting, the same thing for vaporization. Instead, we will replace only just a little details, like the intermolecular forces among liquid are weak, while the intermolecular forces among gases are very weak. But in both cases, vaporization and melting, the intermolecular spaces increase, and of course, the molecules will become more free. Now let's learn a little about the relation between the temperature of matter and the physical state of matter. Okay, we have three states of the same matter, which is water. Solid state is ice, liquid state water, gaseous state water vapor. Okay, when we bring solid state, which is ice, and we expose it to heat, we will notice that the molecules will gain heat energy or thermal energy, and it will change into liquid state, which is water. And when we bring liquid state of matter, which is water, and we expose it to heat, the molecules will gain heat energy or thermal energy once more, and it will change into gaseous state, which is water vapor. This process is called vaporization. And when we bring gaseous state water vapor or matter, and we expose it to cool, it will lose heat energy and change into a liquid state. This process is called condensation. And when we bring liquid state water and we expose it to cool, it will change into a solid state, which is ice. This process is called freezing. So we have four processes: melting, vaporization, freezing, and condensation. Melting, vaporization, freezing, and condensation. Melting, vaporization, condensation, freezing. Now again, we've learned that melting process, it is a change of matter from solid state into liquid state by what? By heating. Vaporization process, it is a change of matter from what? From liquid state into what? Into gas state by what? By heating. Melting process and vaporization process. Now let's talk about matter and molecules. We already know that molecule, it is the smallest part of matter which can exist freely, and it has the same properties of a matter. So the molecules of a substance are similar in properties. Of course, they are similar properties. The molecules of iron are good conductors of electricity. The molecules of wood are bad conductors of electricity, so they have the same properties of their matter. The molecules of one substance are similar in properties, but they differ than other substance molecules. This means the molecules of wood are different from the molecules of iron, and the molecules of silver are different from the molecules of gold, maybe. So each molecule of one matter is different from the molecules of another matter. Okay, substance is composed of molecules, and each molecule composed of atoms. The molecules of different substances differ in their property. He may ask you why, because they differ in their structure. Let's learn about the kinds of molecules. We have two kinds, element molecule and compound molecule. What is meant by element? Element, it is the simplest pure form of matter which can be analyzed chemically into simpler form. The element molecule is formed of similar atoms, not different, similar atoms that combine together, like two oxygen, maybe two hydrogen, so they are similar. Okay, oxygen molecule. The molecule of oxygen consists of two oxygen atoms, so of similar atoms, oxygen and oxygen. So the element molecule is formed of similar atoms. Similar atoms. They must be the same. Oxygen, the other one will be oxygen. Not oxygen and hydrogen, no. Oxygen, oxygen. Hydrogen, hydrogen. So the element molecule is formed of similar atoms that combine together, like the oxygen molecule. We have two types of elements, monatomic element and diatomic element. Monatomic element. What's meant by monatomic element? Monatomic elements are elements which which is composed of one atom. Elements which is composed of one atom are called monatomic elements. Like what? Helium, neon, argon, krypton, xenon, radon. All of these are called inert gases or not gases. And an example of monatomic element which is liquid is mercury. Now let's move to diatomic element. Diatomic elements are elements which is composed of two atoms, like hydrogen, nitrogen, chlorine, fluorine, oxygen, and for liquid element we have bromine. So we have two types of elements, monatomic element and diatomic element. Liquid elements and gas elements. We have monoatomic liquid elements like mercury, diatomic liquid elements like bromine, monoatomic gas element like noble gases, diatomic gas elements like active gases. Now, after we've talked about the element molecule, let's talk about the compound molecule. What is meant by a compound? It's a substance which is formed from what? From the combination of atoms of two or more different elements with a constant weight ratio. What is meant by constant weight ratio? Constant weight ratio means that we all know that water consists of one oxygen and two hydrogen. So you will not wake up one day and find out that water has changed from H2O into maybe H2O2. No, this will take us to another compound. Like table salt consists of one sodium atom and one chlorine atom. So it's always one sodium and one chlorine. Ammonia NH3, one nitrogen and three hydrogen atoms. So this is what is meant by constant weight ratio. This means that they have the same weight ratio always. Water always consists of two hydrogen and one oxygen. Table salt always consists of one sodium and one chlorine. Ammonia always consists of one nitrogen atom and three hydrogen atoms. Okay, let's have some examples for some compounds. Okay, you have to notice that the compound molecule is formed of different atoms that combine together. Like what? Compound like water. Water is a compound. Its chemical formula is H2O. The number of atoms is 3, but the number of elements is 2. Why number of elements is 2 while number of atoms is 3? Number of atoms, 2 hydrogen atom and 1 oxygen atom. While number of elements, we have 1 hydrogen element and 1 oxygen element. So the 2 atoms of hydrogen is considered as an element. The type of atom, 2 hydrogen atom and 1 oxygen atom. Another example, table salt or sodium chloride. Its chemical formula NaCl. Number of atoms, 2, 1 sodium atom and 1 chlorine atom. Number of elements, 2. The type of the atom, 1 sodium atom and 1 chlorine atom. Ammonia, its chemical formula NH3. Number of atoms, 4, 1 nitrogen atom and 3 hydrogen atoms. So we have 4 atoms. Number of elements, 2. Why? The 3 hydrogen atoms is considered as elements. And 1 nitrogen atom, so we have 2 elements. The type of atom in ammonia, 1 nitrogen atom and 3 hydrogen atoms. Okay, that's all for the compound. A little comparison between element and compound. Definition. Element is the simplest pure form of matter that can be analyzed into a simpler form. Compound is a product of combination of 2 or more different elements with constant weight ratio. Atoms. The atoms of elements are similar, while the atoms of compound are different. So atoms of elements are similar, while atoms of compound are different. Examples. Examples of elements like oxygen and hydrogen. Examples for compound like water, CO2, ammonia, and hydrogen chloride. Of course, CO2 is carbon dioxide gas. Now choose the correct answer. Which one of these elements is a solid element? If you know the answer, comment below and tell me which one is a solid element. Which one of these elements is a diatomic liquid? Which one? If you know the answer, comment below. Choose the correct answer. Which one of these elements is diatomic gas element? Last question. Which one of these elements is a monatomic gas element? Helium, boron, hydrogen, mercury? You tell me. Okay, that's all for today. If you have any inquiries, comment below and tell me, and have a lovely day. Bye bye.